Hello, this recording is actually 10.05. They did change the number on me here, and it's on polar coordinates. Alright, so we're in a different mode now in our calculator. I don't think we'll actually be needing our calculator today, but if we do, I'll show you how to change that mode to now we're in polar mode, which is P-O-L, instead of parametric mode, which is your P-A-R. So polar means that we have an R and a theta, and R is the distance from the origin, and theta is how many degrees we're starting going counterclockwise from 0, or your x-axis. So here, our distance is 4, so we would be moving 4 up, and then pi over 2 is our theta, so that means pi over 2 is actually on our y-axis, so we'd have the point right there. Okay. So right here it says, a point in polar coordinates is given. Find the corresponding rectangular coordinates. All right, we do have some equations that can help us find these. So we do know that r squared equals x squared, let's see, plus y squared, but we actually don't want to use this one, I'm sorry. We want to use x equals our cosine theta, because remember on our unit circle, your points are actually cosine and then sine, right? And then y equals r sine theta. So to find x, we know that we have 4 cosine of pi over 2. And cosine of pi over 2 is just 0. So 4 times 0 is 0. And for y, we have 4 sine of pi over 2. And sine of pi over 2 is actually 1. Right? So 4 times 1 is 1. So in rectangular coordinates, we get the point 0, 4. And if you look, they actually are plotted at the same spot in both polar and rectangular coordinates. Okay, next one. Plot the point given in polar coordinates and find the corresponding rectangular coordinates. So again, the distance is 4, and this time theta is negative pi over 3. So about 4 out, and then negative pi over 3 from the x-axis there. Right, so in polar coordinates, that's what we have. Now let's find rectangular coordinates. So remember that's r cosine theta. So let's start with the x. So 4 cosine negative pi over 3. If you don't like working with negatives, we can change this so it is a positive. Remember, we'd have to add 2 pi. So 2 pi is the same thing as 6 pi over 3. So really, we'd be looking for, let's see, 5 pi over 3. And if you have your unit circle present here, you can see that 5 pi over 3. I think it's 1/2, but let me just make sure. 5 pi over 3, yep, is 1/2. So 4 times 1/2 is a positive 2. Good, so that matched up. And now to find the y's, we have our sine of theta. So 4 sine of 5 pi over 3. And then sine of 5 pi over 3 is a negative square root 3 over 2. And to simplify that, we would get negative 2 square root 3. So the rectangular coordinates is x is positive 2, y was negative 2 square root 3. The next one here, the rectangular coordinates of a point are given. and then find two sets of polar coordinates. All right, so if these are the rectangular coordinates, we need to find r and theta. So r is actually found by doing our r squared plus x squared plus y squared. So this is 36 plus 0. So really r equals a positive 6. And then to find theta, tangent of theta equals the absolute value of b over a, or y over x. So 0 over negative 6, so tangent theta of 0. And if we want, we can do tangent inverse, so we can actually find theta. So tangent inverse of 0 is in fact 0. Okay, so the polar coordinates, we can have 6 and 0. There's one of our points, okay? Or we can take the opposite of r, and we can add pi to it. I'm not sure if their answers are actually correct, because if I'm remembering from the online lesson, let me backtrack here. I'm doing this all from memory. To find the second point, there's a couple different things we can do. We can change r to negative r and add pi to theta. So I do believe that this is another point that we can come up with here. Or you can add 2 pi and keep r the same. There's a lot of different rules we have, and they're all listed in the online lesson there. I think they might actually have some of these reversed. So possibly not. All right, we'll have to go back, but I'm pretty sure these are okay for now. Okay, and how about the last one? Again, we have rectangular coordinates. Find two sets of polar coordinates. All right. So again, let's find r and theta. So we take r squared equals x squared plus y squared. Let's see. Now we're going to take the square root of both of those. So let's see. What is the square root? What's 16 plus 36? 52. And if we work on simplifying that, 4 times 13 is 52, so that's 2 square root 13. Okay. And then to find theta, we do tangent of theta equals the absolute value of b over a. So that's your 3/2 there. We do need to do tangent inverse of 3/2 or 6 over 4, depending on how you want there. And we do get approximately 0.983 for that decimal answer. So we can have r, which is 2 square root 13, and then theta, 0.983. And then the next one, remember we take opposite r, and then we add pi to theta. So we'd have 0.983 plus 3.14. And that gives us our 4.124. Okay, see, I'm not going crazy. Here they use the same rules that I did on my previous question. All right, and I got the same answers here. So that's why I think the answers in this one are incorrect. And these are the correct ones. Okay. So here, in fact, are 2 points that we can use. Again, these are polar coordinates. These are not rectangular coordinates. These are polar coordinates.